The Ka-25, known by its NATO reporting name Hormone, was the first Soviet helicopter with a true anti-submarine warfare or ASW capability. While it lagged behind Western rivals, especially in hunting threats below the surface, it represented a significant advancement for the Soviet Navy. Its variants also proved effective in other roles. Today, we're investigating the Ka-25, the helicopter that gave the Red Fleet open sea operational capability. The Ka-25 was essentially an ASW helicopter, but it also had many variants for a wide range of other missions. Although no single rotorcraft could provide a multi-role capability, the entire family played critical roles across all types of naval operations. Because it was economically and technically impossible to build a surface fleet capable of facing the US Navy in the short, medium, or even foreseeable long term, the USSR instead focused on protecting its near waters during the early stages of the First Cold War. In the second half of the 1950s, the USA began commissioning ballistic missile submarines that threatened major Soviet cities from long distances. To counter this threat, the Soviet ASW fleet found itself sailing into the open sea. Still, the nuclear propulsion systems of these submarines, with specifically implemented noise reduction measures, also made them sneakier. When an ASW vessel sailed at high speed, its engine produced significant noise, hindering efficient underwater acoustic detection and limiting the operational area. Consequently, in 1958, the Soviet Navy launched a study to address new requirements, including strengthening its ocean fleet and revising its doctrines and systems. Accordingly, a long-range rapid ASW capability was prioritized. The other significant shift was the introduction of the anti-ship missiles. The naval staff saw this weapon as a high-speed, long-range kamikaze aircraft, one that would fill the gap left by the absence of aircraft carriers. As a result, the Navy needed to improve its over-the-horizon detection and targeting capabilities. All these changes created a demand. Aerial operation capabilities had to increase significantly. In the new era, the land-based Mi-14 helicopters and the BE-12 flying boats would serve coastal waters. On the far seas, IL-38s and Tu-142s would patrol. The Navy would commission 2 helicopter carriers, and also rotorcraft would be organic to many other surface combatants. Because the existing Mi-4PLs, Ka-10s, and Ka-15s did not meet the requirements of the new doctrine, a new helicopter was needed. Initially, the Soviet Navy considered a single rotorcraft for both ASW and over-the-horizon targeting, or OHT. However, combining the necessary subsystems would require a 15-ton class helicopter, which was unsuitable for ship-based operations. Therefore, the Navy adopted the concept of a single machine with 2 variants, one for each role. Kamov immediately began design work and developed the Ka-20, whose NATO reporting name is HARP, as a demonstrator, lacking mission equipment, corrosion protection, or shipboard operational systems. It first took to the skies on May 21, 1961. This day is also recognized as the maiden flight of the Ka-25. The Ka-20 was displayed at the 1961 Tushina Aviation Day. Kamov began working on the actual helicopter and completed its Ka-25PL ASW variant first. NATO has given it the reporting name Hormone-A. The new rotorcraft made its maiden flight on April 25, 1965. Its weight increased fivefold compared to the Ka-15, but its dimensions grew by only 1.6 times. That year, the company delivered the pilot patch of 5 helicopters, and state trials began. A Project 1886 class submarine tender, whose NATO reporting name is Urga class, was converted into a floating base for sea tests. The trials began in 1967 and lasted 175 days, during which the Ka-25 flew approximately 100 hours over the ocean. On December 2, 1971, the Soviet Navy officially accepted the helicopter into service. Kamov produced about 460 Ka-25s in all variants by 1975. With two three-bladed main rotors rotating in opposite directions, the Ka-25 did not require a tail rotor along with a long tail boom to balance its rotational moment. This coaxial rotor configuration improved flight performance by using shorter diameter, lower speed main rotors, and provided effective protection against resonance and vibration. It also used engine power efficiently and eliminated torque compensation losses found in conventional designs. During a turn, the pilot pressed the anti-torque pedal, causing differential rotation between the two coaxial rotor stages, and the helicopter rotated its fuselage toward the slower rotating rotor. This design provided excellent maneuverability, allowing sudden movement in any direction, left, right, forward, backward, up and down, with significant flexibility. The absence of a long tail boom and tail rotor made the Ka-25 compact, which was essential for deployment and storage on ships. To further reduce overall length, the main rotor blades, made from corrosion-resistant ADZ3 aluminum alloy, could be automatically folded using an electromechanical system. Lacking a tail rotor also eliminated the effects of crosswinds, allowing the helicopter to take off, land, hover, and operate in all weather conditions. The all-metal fuselage was primarily constructed from duralumin alloys, which were anodized and coated with AG1OS primer for corrosion protection in marine environments. Steel was used for highly stressed components. Jettisonable sliding doors were installed on both sides of the crew cabin. A sliding door on the left provided access to the cargo compartment, while an emergency release hatch was on the right. The unpressurized cargo compartment could carry up to 12 passengers or up to 1.1 tons of cargo. The helicopter had four-wheel, non-retractable landing gear. For emergency water landings, inflatable pontoons were fitted, but these were removed in the mid-1970s due to significant drag and their 260 kg weight. The Initiat SIPA 2K centimeter wave panoramic radar located in the nose dome detected large ships, life rafts, and submarine periscopes at ranges of 220, 15, and 20 kilometers respectively. It also supported precision bombing and torpedo delivery in poor visibility. On the right rear external mount, the Ka-25 could carry a single dispenser equipped with 3 sonobuoys. With an operating time of 20 minutes, each sonobuoy could detect targets up to 25 kilometers away. In the weapon bay, the helicopter could also be fitted with a dispenser with 18 sonobuoys. The VGS-2 dipping sonar, whether in active or passive mode, had a maximum detection range of 6 kilometers. The helicopter was also equipped with a towed magnetic anomaly detector. Data from these sensors fed into the PVU V1 Jasmine analog targeting computer, which automatically guided the Ka-25 to a weapons release point via a 4-axis autopilot. Engaged throughout the entire flight, from takeoff to landing, the autopilot stabilized the flight path, maintained the hover altitude, and kept the sonar tether vertical. The hover ceiling reached only 600 meters and the operational radius remained limited. However, the coaxial rotor design and autopilot reduced vibration and crew workload, ensuring a comfortable flight and allowing a single pilot to conduct extended patrols. Armament was stored in the bomb bay beneath the fuselage and on external pylons on the right and left, 2 on each. Bulgaria, India, Russia, Syria, Ukraine, the USSR, Vietnam, and both the Socialist Federal Republic of Yugoslavia and the Federal Republic of Yugoslavia were operators of the Ka-25. The Ka-25 PLs for the 5-person crew included a pilot, a navigator, and 2 to 3 system operators. It had a fuselage length of 9.75 meters, a rotor diameter of 15.74 meters, and a height of 5.37 meters. The helicopter's empty and maximum takeoff weights were 4,765 and 7,500 kilograms respectively. Two 900 shaft horsepower Gashenkov GTD 3F turboshaft engines gave a top speed of 209 km per hour. Its cruising speed was 193 km per hour. The helicopter's range was 650 km and its service ceiling was 3,350 meters, equivalent to 10,990 feet. The helicopter could carry up to 1,001 kilograms of ordnance in its weapon bay and be armed with the 450mm AT-1 homing torpedo, the 350mm APR-2 rocket-propelled homing torpedo, and PLAB 250-120, PLAB 50-64, and PLAB MK depth charges. By 1972, the helicopter began to be fitted with two 1,100 horsepower GTD-3M turboshaft engines. This variant was called the Ka-25 PLF. The Ka-25 PLYU could release the 8F-59 nuclear depth charge with a kill radius of up to 3 kilometers. The Ka-25 PLS could launch the VTT-1 Strish wire-guided torpedo. The Ka-25T, whose NATO reporting name is Hormone-B, was the OHT version and 50 units were produced. It featured a larger, rounder nose dome to house the USPIH radar, which provided 360-degree coverage. Typically, the helicopter patrolled up to 200 kilometers from its ship, detecting targets at 250 kilometers and thereby supporting missile attacks at 450 kilometers. Unlike the Ka-25PL, the Ka-25T had retractable landing gear to avoid radar obstruction and lacked a weapon bay. The Ka-25PS, whose NATO reporting name is Hormone-C, was the search and rescue variant. The cargo cabin carried medical equipment, 2 stretchers, and a seat for medical staff. The USSR also operated the Ka-25BT and the Ka-25B-Z minesweeping, the Ka-25IV missile tracking, the Ka-25 ROMB electronic reconnaissance, and the Ka-25 ISK radar calibration versions. The Ka-25PLE was used to locate spacecraft that splashed down in the Indian Ocean. The Ka-25L1, L2, and LZ served as test platforms for research on hydrological and submersible hydroacoustic stations and for trials of new anti-submarine weapons, respectively. Kamov also proposed the Ka-25F gunship, the Ka-25 Shah fire support helicopter for amphibious assaults, and the Ka-25M utility version, but none entered service. The civilian Ka-25K variant did not progress beyond the prototype stage. The Soviet Navy operated Ka-25s on over 40 classes of naval vessels throughout their service. The helicopter played a crucial role in many Soviet naval operations. For example, on March 30, 1970, in the Mediterranean, the Hormone-A's of the Moskva tracked a submerged US nuclear submarine for more than 10 hours. In 1974, the USSR deployed Leningrad with 12 Ka-25BTs to the Suez Canal for mine clearance operations. The helicopters completed 188 sorties and accumulated 339 flight hours. From 1977 to 1992, Ka-25s operating from the nuclear icebreaker Sibir provided navigational support to ships in northern latitudes. Their 360-degree radar coverage and coaxial rotor design, which ensured reliable performance in harsh weather, made them essential for these missions. Due to the Ka-27's limited OHT capability, Ka-25Ts remained in Russian Navy service until the mid-1990s. Meanwhile, the Helix began replacing the Hormone-A's in ASW roles in the early 1980s. After the dissolution of the USSR, Ka-25PLs were retired almost immediately, with even Russian sources describing them as unsatisfactory for submarine hunting. Syria used Ka-25s during its intervention in the Lebanese civil war, primarily for troop and supply transport and observation missions, rather than naval operations. In a similar manner, Yugoslav Ka-25s were used during the Yugoslav Civil War. Later, NATO airstrikes destroyed 2 on the ground in Podgorica during the Kosovo War. With its distinctive appearance, the Ka-25 had a certain charm. Its basic lines have been carried over into its successor, the Ka-27, and have become the Russian style. Thankfully, it never had the chance to prove itself in a war, which would most likely have caused the nuclear apocalypse. Nevertheless, the Ka-25 has taken its place among the unforgettables and has become a first Cold War legend. Thanks for watching our video. And please don't forget to subscribe to our channel and click the bell button to be notified of our new videos. For more contents like this, please consider clicking the join button to support our channel. And as always, we would greatly appreciate all of your likes, comments and shares.